Now we're going to go back to those words, parallel and perpendicular. All right, 2 more clues. Okay, we're going to write an equation of a line. And it says we're going to pass through point 1, 4, and we're going to be parallel to. So let me write this down. It says we're going to go through point, oh, that marker don't work, sorry about that. We're going to go through point 1, 4, and we're going to be parallel to 2x plus 4y minus 9 equals 0. All right. How many clues am I giving you? 2. We all know what that is. 1, 4 is a point, right? What do we do with points? We plot them. 1, 4. Is that 1 point enough to decide what type of line we got? Nope. Right now, I can draw any of the 3 lines through that point. So we got our point. Let me ask you a question. Is that point on the y-axis? Nope. It's not on the y-axis, so we all understand that's just a point. It's not a y-intercept. All right. They give us the word parallel. We're going to hold off on that. What is this thing here? Because that surely is not a point. Well, that's an equation. It's an equation of a line. So you should be able to look at it by now and recognize, oh, I know. I got an x, I got a y. This is a diagonal line. Well, if I want to see a picture of that diagonal line, is it ready to graph? No, it's not. It's not in slope-intercept form. So what I want to do is I want to draw that line on here for you to see it. So just to review, let's get it in slope-intercept form. So to get this equation in slope-intercept form, we want to get y by itself. So we're going to subtract 2x, and we're also going to add 9. And by now, I think you can all do that in your head. So we got 4y equals negative 2x plus 9. But we're not done. Y is not by itself. So we're going to divide by 4. So this equation of this diagonal line, and the way we like to see it, is y equals. Can I keep negative 2/4? No, it's a fraction. It's got to be reduced to negative 1 over 2. X. Can you reduce 9/4? Nope. Okay. So everybody look at that. I gave this to you. You didn't make it up. It was here. I gave you an equation of a diagonal line. You just fixed it so you can draw a picture of it. We all know, looking at this diagonal line, what the slope is. Here's the m, the number that's connected by multiplication, the slope. It's negative 1/2. We know the number behind is the y-intercept. We've already discussed this. The x and y-axis are number lines. Not every number on a number line is a whole number. So if I want to know on the y-axis where 9/4 is, me and my brain have to do some dividing. How many times does 4 go into 9? Twice, with something left over. So when I go plot this y-intercept, it's between 2 and 3. I don't know exactly where in between, but it's somewhere. And then the slope says go down 1 to the right 2. So if I go down 1 and to the right 2, and I plot my next points, you could see, yeah, that makes a diagonal line. All I've done is take the 2 clues and draw them on my graph. 1 clue was a point I plotted. 1 clue was an equation of a diagonal line, so I put it in the right form to graph it. Now we're going to answer the question. The question says, write an equation of a line. That line has got to go through this point. So we have to draw a line through this point. But that line has got to be parallel to this line. Well, everybody look. If this line is diagonal and you want to draw a line through this point that's parallel, that never touches it, do you agree it's also got to be diagonal? Not only does it got to be diagonal, they got to have something in common. If 2 lines are never going to touch, we talked about this, they're going to have to move the same way. If I'm here and I don't want to touch, I would have to keep moving the same way. That word move is slope. So we know when we see the word parallel, that means we got to have the same slope. Well, we knew the slope of this line. You went down 1 to the right 2. So if I want to draw a line through this point that's guaranteed not to touch this line, I got to move the same way. I got to move down 1 to the right 2. Down 1 to the right 2. And you can all look at that picture and say, yeah, they look parallel. Now again, I'm drawing pictures just so this will all come to life for you. The hard part is they don't want you to draw the picture. They want you to come up with the equation, the name of that new line. I got the name of this line because it was given. I want the name of this new line. Well, you know it's a diagonal. So if it's a diagonal line, we have a decision. Do we use slope-intercept or point-slope? If I use slope-intercept, I have to know the slope and that line's y-intercept. Well, I wasn't given either of that information. But I know because these are parallel, I'm going to use the same slope number. So if this slope is -1/2, for my diagonal line, I'm going to use the same number. So that's why they're telling you the word parallel. Parallel is a key to go get the slope and use the same number. Now again, to write an equation of a diagonal line, not only do you need to know slope, you either need to know the y-intercept or a point. So everybody look, here's my clue. Was that the y-intercept? If I look at my picture, that is not on the y-axis. So I'm just given a point. That's why I know this time I'm going to have to use the point-slope formula. I got a point was given, and I was able to look and get my slope. Because if this equation slope was down 1 to the right 2, and I'm going to be parallel, I'm going to use the same number. So now we're going to fill in our formula for point slope. Y minus our y value is 4. Our slope value is the same as this because we're parallel. X minus our x value is 1. And now we're going to work that out to make it look like a diagonal line. Y minus 4 equals, we're going to distribute a fraction. We're going to get -1/2 x. And a negative times a negative is a positive 1/2. We're not done yet. We're going to add 4. Oh my, you're going to have to add a fraction and a number, a whole number. Okay, guys, if I have 4 and you have a 1/2, do you agree we have 4 1/2? Well, 4 1/2 is a mixed number. You cannot write in college math 4 1/2. It's not allowed. You know that could be an improper fraction. 4 times 2 is 8, and 1 is 9. That's 9/2. And that's what your y-intercept would be. That's the equation of the diagonal line. Now, you're going to say to me, Miss Black, it's the same equation. No, it's not. Both of these equations have the same slope because we said they were parallel. But everybody look. This diagonal line's y-intercept was at 9 divided by 4. This diagonal line's y-intercept is 9 divided by 2. And if you think about that, 9 divided by 2 is 4 1/2. And that's where it's touching. This diagonal line's touching somewhere in the middle of 4 and 5. So that is a different equation. Now again, you better pay close attention. If they say to give that equation in standard form, you have something extra to do. In standard form, you cannot keep fractions. So to get rid of the fractions, divide by 2, divide by 2. We know the opposite is to multiply everybody by 2. So 2 times y would be 2y. 2 times a -1/2. Well, that 2 and that 2 are going to cancel and leave you -1x. 2 times 9/2. Those 2's are going to cancel and leave you +9. But that's only half the battle. Once you get rid of the fractions, then you have to get the terms on the same side. So I'm going to take the -1x and add it to the left. So that would be x plus 2y equals 9. That is the equation of the new line in standard form. This was the equation of the line in slope-intercept. Is everybody okay? Good. Our last example, I'm going to use the same information. I'm going to change a vocabulary word. So let me erase. So if you look at our last example, all I did was change one thing in the clue, and it changes up the whole answer. I still say write the equation of a line. I still give you the point 1, 4. I still give you the equation. But now I use the word perpendicular. And that means something different. So again, my Michelangelos and Picassos. If you're not sure what the heck to do, go to graph paper and draw yourself a picture. You know that's a point. You know you can plot it. 1 point is never enough to make a decision about what line we're talking about. That's why you're always getting how many clues? 2. This we know is an equation. It's got an equal sign. Every equation in this module makes a line. You've got to know, because it has an x and a y, it's going to be a diagonal line. Well, I need to see a picture of this diagonal line. It helps me to understand what's going on. So to get this ready to graph, it has to be slope-intercept form. The y has to be isolated. So I'm going to do it again. I'm going to isolate y. I'm going to leave 4x where it is. I'm going to subtract 2x. I'm going to add 9. Then I'm going to divide all the terms by 4. And I'm going to get y equals, there's the 1/2 x plus 9/4. I want to see a picture of this. So I'm going to go plot it. Again, we've discussed this. To graph a diagonal line, you get slope and the y-intercept. Connected by multiplication, behind. This is where you begin. Remember, begin and move. The y-intercept's got to go on the y-axis. So for you to figure out where this fraction is on the y-axis, you got to do some division in your head. 9 divided by 4 is 2 point something. So this y-intercept's between 2 and 3. The slope tells you how to move. I'm going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Okay. So now all I've done is get a visual of the 2 clues. I have my point plotted. I have my line drawn. Now I can at least understand the question. They want me to write an equation of a line, and that line has to go through this point. So I'm about to draw a line that goes through this point. But the line I draw has to be perpendicular to this line. Well, everybody look. Here's my point. I got to draw a line through this point. If I draw a vertical line, would it be perpendicular to the diagonal line? It intersects, but I hate to tell you that's not 90 degrees. So no. If I draw a horizontal line, would it be perpendicular? Now look, you know lines go on forever and ever. So I extend it. If I draw a horizontal line through that point, yeah, they intersect, but that is not 90 degrees. So the only way I can draw a line perpendicular to a diagonal line is to draw another diagonal line. Do y'all see that? That's perpendicular. There's the L. There's the 90 degrees. So now we know we need an equation of a diagonal line. Well, this is going to be tough. You have 2 decisions. Do you have enough information to fill in slope-intercept? Do you have enough information to fill in point-slope? Well, you were given a point. Is that point on the y-axis? Nope. So slope-intercept is out. Because to do slope-intercept, you have to know the y-intercept. We don't know it. So because we just have a regular old point, we're going to use the formula point-slope. Okay? That's how we decide which formula to use. Y minus, we have a y value. It's 4. Equals, what does M mean? M is slope. I didn't tell you up here what slope is, but that's okay. I gave you the word perpendicular. And in the other previous module, we've already discussed this. If lines are perpendicular, they don't move the same way. Their slopes are the opposite reciprocals. So everybody look. We know that this line that we drew in green, its slope went down 1 to the right 2. If my line is going to be perpendicular, my line slope is going to be the opposite reciprocal. So every time you see the word perpendicular, that's what you think of. Opposite reciprocal. And the opposite of being negative would be positive. And the reciprocal of 1 over 2 is 2 over 1. And we all know 2 over 1 is just 2. And that's how I know what my M is. If lines are perpendicular, they don't use the same number for slope, they use the opposite reciprocal. Then we write x minus, and there's my x value, 1. Once you get that point slope filled in, you know to work it out. Y minus 4 equals 2 times x is 2x. 2 times negative 1 is negative 2. Looking like a diagonal line. Let's add 4. Let's add 4. Y equals 2x. Negative 2 plus 4 is 2. Look at that. There's an equation of a diagonal line. Again, read your directions. Sometimes they just want it in slope-intercept form and you're done. But what happens if the direction said put it in standard form? Standard form means to get the x and the y on the same side. I like to move my x to the left. So if I move my x to the left, you all agree it's going to become negative. So this is negative 2x plus y equals 2. That would be in standard form. If you want to move your y to the right, it's okay. If you move your y to the right, it would be negative. So you'd have 2x, you'd move the y to the right, it would become negative, but then you'd have to move the number to the left, and that would become negative 2. Either one of these equations are acceptable in standard form. Some books are more specific than others. Some books don't care which side you move the variables to. Some other books, though, some authors say when you put it in standard form, the x has always got to stay positive. So you're just going to have to read your directions, what they want in standard form. Do they not care who's positive or negative, or do they care? Some books are very specific and say that the first term x has to always be the positive. But in the end of things, what I want you to notice is in 4 modules, we have talked about graphing linear equations. We've talked how to look at the equation, know what line it is. We've talked about how you know what slope it is. And now today, we put it all together, and I said, if I give you the clues, piece them together, figure out what the clues represent as a line, and then write its equation. By far, this is the hardest thing we do with graphing, because you have to think backwards, and you have to know your facts. So all now it's going to take is a lot of practice. But we are done graphing linear equations. I will see you in the next modules to graph something new. Thank you.